talking about the flex force sensor martialized smart glove. Now, the whole reason we did this project was to design an effective, cheap, and easy-to-use method for people to train, essentially. Weightlifters have weights, bodybuilders have stopwatches. But anybody that trains in boxing or martial arts has to have a subjective partner or somebody else to train with. They can't really measure their performance on their own. This will actually address that particular issue. So as you can see in our prototype sketch here, the glove that we're going to be using will have implanted sensors here on the knuckles, here in the heel, palm, and here on the fist. So of course you can do punches, heel, palm strikes, hammer blows. And with this, we can measure, two gloves, we can measure time between impacts, force, acceleration, curve, the strike, and a number of other things.
So we broke the project down into two main categories, which is data collection and data processing. And this semester we focused primarily on the data collection side of the design. And so we had a question that we had to figure out: how are we going to have a compact design that's going to be able to measure force and acceleration, and then get that data in a form that it could be transmitted to some sort of central processing unit. And what we came up with is a design that has a lithium-ion battery that powers low dropout regulators that will then power a flex force sensor in a op amp that will output a small voltage that we can then input into a microcontroller, which the small voltage would be affected based off of what the force of the event on the glove is. So these flex force sensors reduce the resistance with more force that's on them. So then once we get it into the microcontroller, at that point we can process that from analog to digital and then use a low energy Bluetooth to transmit that to our central processing unit.
Next semester we're going to be focusing more on just like processing the data. So we're using, like Todd mentioned, a microcontroller. We're using the TI CC2541. It's based off of Intel 8051 technology. And the reason why we picked it is because it's going to help us get our other metrics like acceleration, velocity, because it's accelerometer built on it. And so next semester we're hopefully going to use that to process our data, and then later develop like a Java applet or maybe even like an app for an Android and iOS, depending on how much time we have in order for the user to see all the metrics in like a user-friendly manner.
Any questions?
What are the G's that you're sensing? What's your target G range?
We're sensing between 0 and 600 foot-pounds on our force sensors.
But I guess you mentioned acceleration.
Yeah, and on the acceleration, we have not pinned down exactly the G's on that. We're figuring out as part of next semester's processing.
Yeah, we just collaborated with force sensors.
Yeah.
This semester we're waiting on force sensors.
Couldn't actually get in.
So the glove's going to be fully self-contained with Bluetooth and everything, or are you going to have to wear another piece?
Yeah, fully self-contained. Each glove will have its own particular method of communicating, essentially. You'll have a very strong housed board further back on the arm so that it will not interfere with your actual training.
How are the sensors packaged in there so that they don't hurt your hand?
And so the sensors themselves, and you can see outside later on, very, very thin, very paper thin, but incredibly resilient. So they can withstand up to 1,000 pounds of pressure, essentially, force rather, and can withstand many strikes, especially when housed within a glove, as you can see here.
I guess you could recruit superheroes to do this testing.
That's outside the range of our scope.
I'm very curious. So once you finish your design, right, you have a series of performance metrics you're trying to achieve. You have some customers that you're trying to target. What type of performance evaluation do you anticipate in phase 2?
So what we really want to get, especially, is force. Being able to show someone how to punch properly is part of this. punching with these two fingers will usually end up breaking fingers. By being able to measure exactly how much force is on each knuckle, we can teach the person, you only have these two fingers because they don't have more of the bone, and it won't break as easy. And so, not only that, we want to be able to show how fast your combo punches are, how fast you can deliver a hammer strike, all sorts of different things that people can use. I mean, it's basically going to be tailored to you, whatever you want to do. If you want to have highly detailed information, you can have it. If you want something simple, there you go.
I'm asking how you're actually going to protect it.
Oh, I'm actually part of a martial arts group. I'll be an instructor next week, actually, and I have plenty of students who
I did martial arts as well.
We all want to kiss this.
Are you two going to face off?
No.
One last question.
Says beautiful.
Oh, I was the main idea person, and they eventually led it to, well, I had originally another idea, but this is what it culminated as.
I worked on most of the technical design and came up with the way that we set up the op-amp in order to get the right values that we needed. And these two are working on the microcontroller, on how we're going to be able to interact with the microcontroller for our, there's a learning curve that we're learning.
I'll be trying to come up with some sort of Java applet or program next semester to process it.
And then we all participated. We borrowed a mechanics lab here and brought test equipment in and used the mechanics lab in order to get, test the data so that we could know what our range is on our voltage output depending upon the force that we have.
That's where our graphing is coming out here.
Make one quick comment. Almost all the teams that present here usually pick one person to give the whole presentation. All four of you contributed to this presentation, and you did it in a really nice seamless way. You did a good job.
Thank you.
Right, I'm very anxious my keyboard skills are not very good. I don't think it's yet over there. It doesn't really work, maybe on a regular screen it works better, but then on the screen